Okay, I make that 3:30. Yeah, so we'll begin this webinar now. So first of all, thank you very much, everyone in attendance. I appreciate how busy everyone is. So yeah, thank you for taking the time out to listen to this webinar. So let's begin. Hopefully this is going to change. Yeah, right. So quick topics of conversation. So an intro to Raytec. This will just be a very brief introduction. We're going to talk about the benefits of using our products and how they can help in your projects. We're going to have a big focus on, well, mainly driver identity and a little bit of LPR as well. We'll look at what products are available for you to get these the results that we're going to talk about. We're going to compare our products to different technologies out there as well, and then finish up with support tools available to you guys. Okay, so here's the brief introduction for anybody who is not too familiar with Raytec. We were established 2005. We have 2 offices. So we've got our headquarters where everything's designed, manufactured. That's in the north of England. And we also have an office in North America as well as a couple of sales offices around the world. We have more than 600 product variations as well. So whether that be for security, whether that be hazardous area, traffic, we have multiple products available. And we have an annual turnover of $23 million with 70 people working for us worldwide. So just also for anyone who didn't know, everything that we do is designed and manufactured in the UK. So we don't manufacture in China or anything like that. Everything is done in-house. That includes design as well. So we have full control over everything that we do. And we operate in two main markets. So we have the security, which covers the general surveillance, but it also covers the traffic range of products as well. And although not of interest as much to you guys, we do hazardous area as well. So that would be general area lighting for things like oil rigs, oil refineries, power stations, that kind of thing. So just so you're aware that it's available. And here's a couple of examples of some projects that we've done for hazardous areas. So this was a power station, I believe, in Australia. So these are all our lights that we've done. So we designed that project and we installed it. And then here's another area of that as well. So we'll go straight now to the benefits of using Raytec lighting. We'll start with general surveillance. So key considerations for these kind of applications. So the first thing you want to know is it going to be infrared you need, or is it white light? What distance do you need to cover? So the distance from the camera to the subject area is very important. What angle you need as well. So is it narrow angle? Is it wide angle? And the type of camera. So fixed camera, PDZ camera, multi-sensor camera, that kind of thing. And another question we would ask as well and consider, are you going to use video analytics for your project? Because typically when you're using that kind of intelligence, you would need more light on scene than you would for, say, a general standard CCTV application. So here's a couple of examples. So this is using our infrared, and this would be what we would expect to achieve every time when you use our product with a good quality camera. So you can see the image on the top right there is without the light, and then the image there obviously with the light, and it's using infrared. So the person in the control room gets a perfect picture, but the people being watched, they do not know they're being watched because infrared is invisible to the human eye. One thing that I forgot to mention earlier is any questions, please just go to the questions tab and just write them as I go along, just so you don't forget it. And then when we come to the end of the presentation, I'll just answer them there and then. So yeah, please utilize the questions tab, and we'll answer everything at the end. So hopefully that changes. Yep. So also long range surveillance as well. So this is an example of a 300-meter project. So we can see that when the camera is zoomed out, we're getting a very nice image. But the important thing is what happens when the camera zooms in as well. So we can see that area here when we zoom in 300 meters away, we're still getting a good image. Because what you find a lot of the time is if you're using either a low quality infrared that's not matched to the camera, or if you're using a camera with integrated, what will happen is usually when it zooms in, it looks very good because it's got a narrow angle light that'll zoom in to the far distance. But when you put the camera back to its wide angle, it's going to be quite spotty in the middle and dark on the outsides, which is certainly what you don't want to get a good image. More detail is imperative to us as well. So the other images that I showed you were some testing that we've done. I mean, this was taken from an actual application where the person was caught and prosecuted. So the idea is, if you want to get extra features such as facial recognition, such as what clothes somebody is wearing, all the details like that, you should use dedicated separate infrared where it matches to the field of view of the camera lens. And this is just a little example of such an image. And then next you have for our panoramic lighting. So this would be used either for a PTZ camera or a multi-sensor camera. So this one unit here, you can see it's three separate panels, but it's one product code. This is 180-degree illumination. So we'll take a little look at that. I'm hoping that the video is going to play smoothly. So apologies if it's a bit jumpy, but that's zoomed in, that license plate zoomed in from 150 meters away. Then we can see when the light switches off, you're getting a little bit of an image because it's a low light camera, but it's still not good enough to get details. And what you'll see is when that same camera zooms in a bit further, then we switch the light off, it struggles even more because as the camera zooms in, it's getting less light, it's utilizing less light, so it struggles, and you can see there. Then we turn the light on, and then planes are probably at about 100 meters away, and we can obviously read the characters on the side of them. And then you can see the camera panning around. So this is just to give you an example of this panoramic light is achieving a full 360 degrees. So wherever that camera looks, it's going to get perfect illumination in every 150 meters in every direction. Obviously, this is a pan and tilt camera, but if you were using a multi-sensor camera, it means that if a crime happens in any part of that image, you've got enough light that it's going to capture everything that's happening. So we'll see you've got a person in the distance there. They're at about 150 meters away. So we're not going to get identity or anything like that, but we can see there's a person. And then when the light switches off, the example that I talked about, the more it's zoomed in, it will struggle, even the low light camera, when the light goes off. So I'm going to fast forward this video a little bit. And then the person's probably walking to about 100 meters away, and we can see as they get close to the camera, we're starting to get recognition and things like that. A lot more details. And then switch the light off, and you can see the difference there. Okay. So next, video analytics need more light to see. So I know that we've got a few of my friends on this webinar who specialize in video analytics. So they'll be able to obviously comment a lot more on this, but generally the analytics they need more light than your standard CCTV image, depending on what kind of analytics are being used. Obviously, if it's stuff like recognition, object detection, that kind of thing, you need more light there. And if you've got a bad image, there's two main problems that are going to happen. First is it's either not going to make the detections, which is obviously, depending on the site, that could be disastrous, or it's going to get detections but at a very low accuracy. And also on the dark areas of the image, what could happen is, depending on what kind of intelligence you're using, because it's dark, it'll become noisy, and it might see that noise as a kind of movement. So it might cross-line detection. It might think that somebody's crossing the line. It might classify something incorrectly, that kind of thing. So it's very important that you have the correct light level for the analytics, whether that be infrared, whether that be white light. So next, this is a part that I like to focus on quite a bit because it seems to be a hot topic at the moment. Driver identity, so seeing through windscreens. Quite a new thing, but there's a lot of requirements out there for it. And obviously license plate recognition we'll touch on just a little bit. So key considerations, obviously we talked about for general surveillance. We're now going to talk about the considerations for LPR and driver identity. So some different things you need to check. So shutter speed and the speed of the traffic is very important. Got a slide on that next and how lighting impacts that. Type of plate is important as well. So getting license plate recognition in the UK is quite easy because the plates are made of only 2 colors. You can use a black and white camera with infrared to get that. It's highly retroreflective, so it's very easy to do. Obviously in the the GCC, you've got other factors to take into consideration. You've got colors which you need to distinguish, so a lot of the time you need to have white light to get plate recognition. Also, some territories, if the plate is not retroreflective, it means that you need to consider different things like a different wavelength of light or the position of the camera compared to the plate. All things you need to be we need to consider. For windscreen, seeing through windscreens, ideally you want to know the type of windscreen as well. So if it's a standard clear windscreen, that's a lot easier than if the windscreen has a tint. Is it a low tint, medium tint, a high tint? All challenges that we face. Infrared or white light, again, as similar to the standard surveillance. And also whether it's pulsed or constant light. So pulse lighting, it has benefits because you can pulse, because it's not on all the time, it's pulsing very fast. You can have it 3 to 4 times the normal power of constant light, but it requires specialist cameras which allow the light to synchronize with the shutter speed of the camera. And then you've got the position of the light in the camera. So this would be mainly that you don't want to be you don't want it too tight, the angle. So 30-40 degrees, you never really want to go above that, because what will happen is the camera will struggle with the angle, but also the light, even though it's retroreflective, if you hit it from too much of a tight angle, it's not going to bounce back towards the camera, so it's going to be a little bit more challenging. The power of the light you need to consider, certainly when seeing through windscreens, and the wavelength of the infrared. So we'll talk a bit more about that. So let's look at shutter speeds and how this affects the image and the lighting as well. So typically your CCTV cameras for general surveillance are probably going to be around about 1 in 50th of a second. So what does that mean when you're going 70 miles per hour or 112 kilometers? It means that the car has traveled 62 centimeters by the time the shutter has closed and then opened again. So depending on what angle you're using and things like that, that'll cause significant amount of motion blur. So you're probably not going to see, very unlikely you're going to see the license plate. It's going to be too much blur, and certainly if you're seeing through windscreens, it's going to be blurry as well. So a lot of the time people will set it to 1 in 1,000th of a second, or even 1 in 2,000, and then that's only traveled 3 centimeters. So when you look at that on a screen, you don't notice it. So you're going to get very little motion blur. So analytics and everything like that can work properly. How does that affect the light though? So if we look at shutter speeds on a simple candle image, we can see the bottom right has got the slowest shutter speed, 2 times in a second. We can see that's very bright, potentially overexposed. And then the same image, when we do 250 times a second, you can see it's a lot less visible. So if we look at these examples again, to get the same kind of image, 1 in 50th, when you go 1 in 1,000, you essentially need 20 times more light. So that's why it's very important that these considerations are taken into play. What you also need to look at as well, though, is yes, you need 20 times more light, but if you're looking at a plate that's highly retroreflective, you probably need a little bit. It's not as high as that, the amount of light you need extra. So lots of factors to take into consideration here. So let's look now at slow moving vehicles with a standard shutter speed, and how the image looks and how we can see through the windscreen. So we can see there we're getting a very nice picture through that windscreen, but you can see back there this plate is highly overexposed, so we're not going to read it. So we've got a good light to go through the windscreen, but essentially not to see the plate. And bear in mind this is a UK plate as well, so very retroreflective. So next we'll show the example of, yes, it's possible to see through windscreens, but you do need a lot more power. So we can see there we've set up the lighting so you've got a good amount of light to see through that windscreen. It's angled so we can get a good picture there. But you can see when that person sticks the head out the window, it's highly overexposed. So just to give you an idea, we might have a light that says let's say one of our lights we say does 100 meters. That does not mean you can go 100 meters and see through a windscreen with that same light. Next we have is an example where we have put the shutter speed to 1 1/1000 with standard 850 nanometers. So yes, the car is stationary right now, but even if that was going 70 miles per hour, we're going to get pretty much the same image quality as that. So 850 nanometers is probably industry standard wavelength for infrared. It's most, 90+% of the cameras are using that kind of wavelength because it's perfect for CCTV and it's not very visible to the human eye when you look directly at it. But if we change that to 730, you can see the difference. So 730 nanometers, a little bit more visible when you look directly at it, but it's a much better wavelength at penetrating the windscreen. So you can see, I'll just go back a slide. So we'll go back. We can. It's a lot more blurry there. So yes, the car, everything like that looks absolutely fine. But as you go through the windscreen, we're probably not going to recognize that person, and you can see things even like the pattern of the seat. We're seeing a lot better with this wavelength as well. So definitely 730 nanometers is what we recommend for seeing through windscreens. And what we'll do is as well, I ran these same images through some analytics as well. So object detection analytics, it classifies, it detects the objects, whether it's a car or a person. That's all I set it to. So it detects the car at 100% accuracy, but it's not finding the person. So even though very little difference to the human eye, we can see that we'll go 730 nanometers, and the analytics went from not detecting it to 92% confidence that that is a person inside the car. So obviously, if you had an application where you're using analytics we've worked on ones where they're doing multiple occupancy lanes, where analytics will all automatically detect if it's just one person in the lane, and then obviously issue that person with a fine. Yeah, so for that, using 850 would essentially not work. You do have a threshold with these as well. So the initial threshold was set to only give me a detection if it's above, say, 60% accuracy. So I did lower the threshold, and it would only detect that person once I lowered it to anything from 30% accuracy. So even though it doesn't look loads different, it'll only detect that with a 30% accuracy. So obviously the neural network will have been trained on good image quality like this. So obviously with this image, it's not going to be able to get some of the edges and whatever features that it's been trained on. So next we'll look at day mode as well. So to get good quality images through the day, you don't need to use our lighting, but I like to do this as an educational thing as well. It's just so you guys can get 24-hour perfect images through the windscreen. So we can see here day mode, but daytime produces some extra challenges, and that would be the reflection on the windscreen, depending on where the sun is and things like that, if there's clouds in the sky, etc. So we can see there's a person in the car but we cannot really extract any more details than that, and certainly analytics is not going to perform well with that at all. So how do we conquer that? You add a polarizing filter. So this one here was just a cheap off-the-shelf polarizing filter that I used, and you can see the difference. We've went from that to that at a very low cost. So obviously to get the 24-hour surveillance, you need to consider not just the lighting side of it, but how reflection and things like that during the daytime. And that's at 5 meters. We'll also look at a little bit further away as well. So this is obviously daytime, 25 to 30 meters away, and this one's using some analytics, and the image is good enough that we're able to detect that that person is using a mobile phone when driving. So just a couple of projects that very briefly show you. So one of them using similar kind of technology, Dubai Police, where they're using more than probably more than 300, 400 of our systems now since I last updated this. So they're using it for traffic enforcement. So you've probably seen these towers for anyone in Dubai. You've probably seen these towers scattered around the city. So these are they're not for speed. They are to detect if a car has illegally cut someone off or change lanes when they shouldn't and that kind of thing. So then it would automatically issue a violation warning on that. And then we also have Al Quwain Police in the UAE. So they are using a combination of both white light and infrared. So the infrared is to see the license plates, and the white light is to see a general overview of the scene and the driver as well, and to get the color of the car. A lot more information from the white light. So that's utilizing both technologies there. We've got a lot more across the GCC, but these were the only ones I was allowed to essentially show images publicly. So what products are available in terms of both the infrared, the white light, the 730 nanometers? So it's all in our Vario 2 range. So you've got anything from the small 10 watt unit to our big 100 watt unit. So this one is going to give you up to 100 meters distance. This one's going to give you up to 500 meter distance with a single panel. So let's take a look at the Vario I-16, which is the big one in action, achieving 500 meters. So going back to what I was talking about earlier, where it's very important to us that, yes, we've got a good picture when the camera is at its wide angle, but how does it look zoomed in? So you can see in the distance there, you've got a little dot here. That little dot zoomed in at 500 meters away is this picture here. So, we're getting, we're pretty much able to read the writing on the side of the plane at 500 meters away. So these people would have absolutely no idea they're being watched. So 500 meters is not a common application, but we've done a lot of them for military, for offshore, not offshore, sorry, for onshore looking offshore kind of applications, airports, that kind of thing. We also have a fairly recent product, which is the hybrid, the Vario 2 hybrid. So this is available in standard and also IP. So what you get is two things in one. So you've got a white light and you've got an infrared as well. So in infrared, we can go distances beyond 300 meters, and then the white light, you typically get less distance with white light. You're probably talking about 200 meters with the same power white light, but one product can cover both of them. So an example of how that can be used. So I mentioned it can be IP. So you could have either you could automatically have it triggered by HTTP, by VMS, or you could have it triggered by a person in the control room doing it manually. So let's say we're using a PTZ camera, looking long range, and we can see someone in the distance. Great, we'll put it at 100% power. Somebody comes a little bit close, that power can then be reduced to a good power level to see that person very clearly on the scene, so they're not overexposed or anything like that. And then because it's got white light, that could automatically trigger a flashing deterrent as well. Because what we find is a lot of the time people aren't so concerned about getting a good image and prosecuting the person and going through that whole process. They're more interested in deterring the crime, so they don't have to worry about that person again. So we've got a user interface here. So this is an example of the instant access that the person in the control room could use. They can turn it on, change the power, boost it, deterrent feature. But you've also got the advanced settings as well. So you can essentially tell the units how they're going to perform during day-to-day operation, save it, and then you don't need to worry about them again. So this makes setup and commissioning very easy, very cheap. So you don't need to climb a ladder and play around with the settings or anything like that. You can all do it from the comfort of the control room. So, you know, if you've got a big site, something like that, you could have these as a separate group along the fence, so they can all be triggered together by alarm, by HTTP detection, anything like that. You could have this as a separate group. You could have car parks as a certain group, so they could be at a low power, and then when a car's detected, it could come at a full power. So many things you can do with it. And we also have many integrations as well. So this is just an example of a milestone integration, which is it's a free plugin, so there's no need for a license. But we've got loads of other integrations, Axis integration, you've got a Vigilon integration, and many more as well. And I mentioned you can do it by HTTP commands, so you don't even need to have a full integration with anything. As long as your camera or the device can send HTTP, that can tell the light to do whatever you want it to do. So this is what one of the products looks like physically. So what you have is multiple lenses. So you order one product, and that one product can cover pretty much any angle. So you've got 10 degree, you've got 35 degree, 60 degree, 80, 120. So it just means that if you want to move the light somewhere else or change the angle of your camera, you don't need to buy another light. And the important thing is it's got no moving parts in it as well. So the lifetime is not reduced by any part that's moving and could potentially fail. That's why our products have got a warranty of 5 years, but they're going to last way beyond 10 years. I mean, products that I sold in Dubai more than 10 years ago are still up and running, even in those climates. Absolutely no issues whatsoever. They come with hotspot reduction technology as well as a standard feature. So image on the left, where normal IR, so you've got, I mean, it's usable, but you've got an overexposed area here, you've got a dark area here. With the Vario, it guarantees even illumination across the scene there. So let's compare it to some other technologies out there. So Mythbuster, what we hear quite a lot is low light cameras. They are enough to see in all environments. So let's take an example here of not an environment with no light. We'll do an environment with street lighting. So it's pretty well lit. So no Raytec and then Raytec. I mean, looking at this from an image, I mean, you'd probably say that you don't need the Raytec, which I agree. If you only want to see cars coming in, that kind of thing, a brief overview, then no, you don't need Raytec. However, you can probably, it's quite hard to see, but there's a guy lurking around the bush there where we can see a lot more clear there. And then when we zoom in, remember I mentioned that the more you zoom in, the darker it gets. So as we zoom in, we can tell that that's a male, a white male, but we've got no idea any other details about the guy. Whereas here, we're going to get facial recognition, details, you know, we can almost see the make of his jacket and everything like that. So depending on the application, if you need high security, a lot of information, then you should use dedicated lighting for the camera. And then we've got a little video we're going to show here. So remember I talked about the small Vario 10 watt unit. So this is a little demonstration where we compare our small unit to a high quality bullet camera side by side. So the Vario, yeah, uses 10 watts of power, very small. It's our lowest cost unit and it's capable of 100 meters. So PoE, low voltage mains, whatever the power requirements, it's we have an option for it. So 10 meters away comparison, obviously Raytec on the left, bullet camera on the right, there is no difference. So applications for 10 meters, you probably say that you do not need to use external IR. Distance on the now is 40 meters, and then we can see it's starting to get a bit of a difference. So the actual subject is, it's okay, but as it starts to get further, it's becoming more difficult. And then we'll go to 60 meters, and you can see now that the camera is struggling to focus because it doesn't have enough light, and the autofocus is not working properly. So typically I would say anything above 40 meters or more, separate IR would help get much better images. And then another little video to show us it's an old one, but it's a good one. So this was taken from an application a long time ago where it's using a bullet camera. So with bullet cameras, you've obviously got the LEDs around the camera, and LEDs are, even though LEDs are efficient, they still cause heat. And whenever you've got a heat source, it attracts insects. So we can see here that it's a long video, so I'll just fast forward it a bit, but we can see that a spider has starting to build his web over the camera lens because it's warm. It's a great environment for him. And then gradually it's covering the whole image, so you're going to get absolutely zero picture. We can see the spider's overexposed from the lighting. So yeah, zero picture. And then if you're using any kind of analytics with that, it's just going to get alarm after alarm, false alarm, all that kind of stuff. So in terms of our distances, so whenever you look at a Raytec data sheet, the maximum distances that you see, so whenever I talk about 500 meters, if I talk about 300 meters, that kind of thing, you know that you're going to get guaranteed illumination on scene. And the reason that we sort of publish this kind of information is what we tend to get a lot is, if you, let's say you've got a copycat competitor company, they will, what often they would do is they'll look at Raytec data sheet, they'll say, okay, this Raytec unit does 100 meters. Let's just say ours does 120 meters or something. So it means that if anyone's doing a lazy job of specifying, they're just looking at data sheets only, nothing else, then the other product might look better. So that's why we test all our units. Every single unit's been tested. So with white light, the maximum distances that you see are going to give you a minimum of 3 lux. So as you're probably aware, the majority of cameras are going to work off 1 lux, 2 lux, and we're guaranteeing 3 lux. With infrared, it's not measured in lux, it's measured in milliwatt per centimeter squared. But just to give you a bit of context, 0.3 is going to give you a decent image, whereas we guarantee at least 0.35. It's because we would always rather over deliver. That's why we will never get a complaint about a Raytec unit not meeting the distances. So as I mentioned earlier, that Raytec, everything that we do is in-house. So you've got the manufacturing process, you've got the design, the R&D team, the technical team. It means that if there's ever a bespoke application, the process is not too difficult, and we can usually do it. Depending if it's a feasible project, a reasonable size, then we can build a specialist product to suit the majority of applications. So you can see some examples here. You've got a traffic light system, intelligent traffic light system, which was in Saudi. We've got a dedicated housing lighting setup for license plates, under vehicle detection that we built for a big company who do that kind of thing. And then you've got one here for swimming pools where they're using analytics to detect if somebody's drowning or not, without having to rely on a lifeguard only. So yeah, all that's available. So any specialist application, feel free to speak to me about it, and usually we can do that. I'm not going to talk too much about this, but just to make you aware that we sell it should you get any applications. So street lighting range, it's a low cost, very high quality product. So if you've got any project where it's not just for the camera, you also need general lighting as well, we do this product as well. What we also do, we're coming towards the end of the webinar, but just to talk about our support services. So whenever you are working on a project that needs white light, we offer a free lighting design service. So that's done in either 2D or 3D. And what we can do is we can essentially model the site. So you could get a nice 3D drawing, a walkthrough simulation if you want, but importantly, it comes with a full report where it's going to show the lux levels, the average lux minimum, that kind of thing. And the idea is this can be presented to your client, your end user, before they've committed on any units, just to prove the concept of that. So here's some examples of a perimeter sterile zone, power station there as well. And yeah, that brings us to the end of the webinar. Does anybody have any questions? Oh, I've got a question here. Infrared separate unit. Infrared. I'm not sure. So the question about infrared is separate unit or one unit does both. If you're referring to infrared and white light, it's available as one unit. So one unit, half of it can be infrared, half of it can be white light. So essentially, you only need one cable run to do both. Is there any other questions? Yeah, my pleasure. I'm hoping I can see all these. Oh, right, okay, hang on. For some reason, it's minimized, so I can barely see these questions. One moment. I'm just going to consult my colleague to see if she can see them more clearly than I can. Hi, Buzz. Yes, that is indeed my car. I wish it was a Porsche, but unfortunately not. Okay, so I'm going to have to make the best of this bad situation where I can barely read the questions. Yes, Mohammed, this is recorded, so it'll be my pleasure to send it to you. Do you have any complaints where 850 nanometer IR harmful to animal eyesight? So that is a good question. So animal eyesight, human eyesight, is both the same. I think it'll probably come under the same kind of thing if you're talking about as in a safety issue. So as long as it's more than 1 meter away, it's either 1 or 1.5 meters. I'll have to double check. Using our most narrow angle, then it's all right as long as it's more than 1 meter away on that, and that's using the 10 degree. But we've got testing and documents that that state this as well, and I can double check and come back to you, but I'm suspecting that it would be similar kind of thing for animals. Okay, so are the lights integrated? What are the controllers? So you've got a couple of choices. So in order for them to work, you don't even need to connect it to anything. You don't even need to connect it to the camera. So as long as you plug the light in, and then the light is where the camera is and it shares the same field of view, it's going to get the picture at nighttime. But we also have the IP one as well. So it's RJ45 essentially, and then that can then be controlled with the rest of your IoT devices as well. So similar when I was talking about the hybrid. What else? Are APIs available for integration from Raytec? Yes, they are. They are available. So just contact us on that. We can send them over. Absolutely. Separate unit. We've seen that one. Does it function automatically? Yes. So it'll either come on automatically at nighttime with a photo cell, or it can be triggered by PIR, or it can be triggered by, like I said, by the analytics of the camera, by the VMS. So yes, there's multiple options available to control it automatically. When it comes to video analytics, is it possible to do the processing in live video? Yeah. It's possible to do it in live video. I mean, that'll come down to the analytics side rather than the light side. So yeah, I mean, I've processed them on live video. So as long as you've got a good enough GPU, depending on what kind of analytics, some use more horsepower than others, but yes is the answer to that question. Can we have both infrared and white light running at the same time? Good question. No, you can't. And I'll tell you why. So with the hybrid, even though it's using only half the LEDs infrared, half the LEDs white light, you're still getting the same distance as you would with using a full panel of infrared or a full panel of white light. So you're essentially getting 2 units for pretty much the price of one. But because you're getting extra power out of it, they run harder, so you can't have them both on at the same time. Any others? Could the illumination systems be used for real-time flashing? Yes, absolutely. So we've got you can either flash the standard unit by an open closed circuit, but if you want it very fast, within nanoseconds kind of thing, we have a the pulsed star range, where it can be triggered by what could be triggered by a dedicated camera through TTL, or through, even I've had people triggering it through Raspberry Pis and things like that. No problem. Regarding the application, if we need to connect the light to ANPR camera so that we can see the car plate at night, moving it around. Fast moving, yeah. So for your fast moving cars, yeah, you can connect it to an ANPR camera, no problem. But as you mentioned, so 70 miles per hour, you would need typically just a bigger light. But we've had so much experience doing this over the years that we could, pretty much recommend a unit for you if you tell us the site, what distance you want to see, how many lanes you want to see, and the shutter speed that you've got the camera set to. So yes, we have dedicated lights to that. You could do it with our constant light without no problem. If it's an ANPR camera that allows for pulsing, then you could use our pulsing range and get extra power as well. Let's have a look at the next question, specifically for fast moving vehicles. Yeah, Raytec products are rated to IP66. Yeah, IP66. Can be done with normal camera, not an ANPR camera. Yeah, can be done with a normal camera or an ANPR camera. Yeah, we've seen we've got traffic applications where it's using the standard video surveillance camera, but also ANPR cameras. Yeah, for the video analytics results, yeah. I mean, the analytics companies would be able to tell you in a lot of detail, but I tested myself, so it's not really the light, so it would be the processing that you're doing in the back end. So yeah, it can come up on the live video. So whether I've tested it using CV2 and Python, and using like a TensorFlow kind of video analytics. So yeah, it does, and I can speak to you offline on this as well if you want. At Raytec, what angle Raytec light to the camera? Usually you would put it where the camera is, so directly below the camera. If it's a fixed camera, you can have it directly below. If it's a PTZ camera, I'd recommend going at least 1 meter below the camera, as long as they share the same field of view. So if you're using a 30-degree camera, I'd use a 30 or 35-degree Vario unit. We don't have one, so we don't do solar systems ourselves, but the product can be powered by multiple voltages. So whether it's 12 to 24, whether it's mains, PoE. So we've had applications where people are using their own batteries and their own solar setup. So yes, it can be used, but we don't supply the solar system. Is there any effect on fog, rain, snow, length and quality? Good question. I like these questions. So yeah, in answer to that, there is an effect of fog. So what I normally say is it's hard to determine the length because you don't know how thick the fog is, how thick the rain is. But I'd always say, like, if it's daylight and then fog happens, how far can you see? So it's kind of similar question. So yeah, you are dictated by that, and I mean, generally you can get further through the fog. You just need more light, but it's very difficult to predict these things. Difference between IR and white light applications. So yeah, what's the difference between IR and white light applications? So infrared, you can go advantages of infrared. You can go further distances, so distances up to 500 meters. With white light, you tend to get a little bit less distance. But white light, you can get a colored image. Infrared, you get a black and white image. But with white light, it's light pollution. You know, if you're using it in a built-up area, people might complain. So both have advantages and disadvantages over each other. I'd say we sell 80% infrared compared to the rest white light. What lux range for Raytec light that is required for cameras? Depends on the camera. I mean, camera data sheets will say 0.01 lux, but you know, it's not. The camera manufacturers will agree it's not. That's not the case. So probably 1-2 lux is a good light level for the camera, and it depends on the megapixel of it as well. Are there hybrid diffusers with different angles? Yes. Yeah, it would be one diffuser for the infrared and the white light. So question was, are there any hybrid diffusers for the IR and the white light? So yes, but you use one lens to cover the both infrared and white light, so you can't have different angle for each. Do the long distance cameras used with motion detected automatically? Or like zoom in to show the activity of the live stream? Yeah, I mean that. So with the Raytec, ours is not really zoomable, but we would cover the whole area. So it means that if the camera has detected something and then it zooms into that area, we are guaranteeing that it's got a good illumination through that whole scene. So yeah, it's possible, but that's the handshake between the camera and the analytics. Let me go next question. How long is the distance that's covered for ANPR and perimeter fence? Are there specific lights for applications? Yeah. Perimeter fence is very easy. So for a perimeter fence, you can look at the Raytec datasheet and say, okay, this does 100 meters at 30 degrees. That's what I'm going to use. With ANPR, you would usually just speak to us separately because it's, as I mentioned, it depends on too many other factors on that as well. So typically you'd get less distances. So don't use the distance charts for ANPR. Just talk to me. Any consultant in mind to discuss product requirement? That would be myself. So I manage all of the GCC, and when we're not going through global pandemics, I'm normally out there 1 week a month. So yeah, I can certainly help with that. We also have distributors who are in the area all the time as well. So what I'll be doing is I'll get an email out to everyone with my email